algebra to memory because you'll probably see a couple of problems on the EOG for slope 2. Okay, Unit 1, we talked about real number systems, rational and irrational numbers. I've listed here all of our natural numbers. Remember, natural numbers are our counting numbers. So these are the numbers when you were in kindergarten and the teacher said, okay, boys and girls, everybody count to 10. And you say 1, 2, 3, 4, and so on. Those are our natural numbers or counting numbers. So think back to the first numbers you learn. We always learn 1 through 10, right? And it goes on and on infinitely, but we always learn those whole numbers, right? Then we move on to from natural accounting to whole numbers. And the only difference is that includes 0. So when kids are learning how to count, we don't say 0, 1, 2, but we know that 0 is part of our whole number set. So that is a step up from natural because we're just adding the 0. Then when we get to integers, we're adding negative numbers. So you notice every single time we're going to the next box, we're moving to the left of our number line. So we started with 1, 2, 3, 4, and then whole number we add a 0. And then integers, we start adding negative numbers. So those are all positive and negative whole numbers. And then rational numbers are numbers that don't necessarily have to be whole numbers. So they could be fractions, they can be decimals. Square root, like the square root of 81 is 9, so we know that's a rational number, and there you go. So all numbers might not necessarily fall into all categories, but if a number is rational, it's more than likely going to be an integer, it's more than likely going to be a whole number, and it quite possibly could be a natural number too. So the question might ask you, classify this number, like of all the things it is it rational, is it an integer, is it a whole number, is it a natural number? So those are things you just need to know. And then remember, irrational numbers are numbers that cannot be written as a fraction, right? They don't repeat and they don't terminate, because we know if there's a terminating decimal, we can write that as a fraction, right? Put it over 1,000 or 1,000,000 or however many numbers there are. And we know if it's a repeating decimal, we can just put it over 9 or 99 or 90, depending on how it repeats. But irrational numbers go on forever, right? They don't repeat, they don't terminate, so we can't really write them on a sheet of paper as they are. So pi is the most famous irrational number, right? Because it goes on, doesn't repeat, doesn't terminate. Same thing with things like the square root of 13. Anything that we're trying to find the square root of and it's not a perfect square, we know that it's not going to repeat and not going to terminate, so we know it's an irrational number. Similar figures. We just got done talking about similar figures, so this should be pretty easy. Remember, we just line up our sides. So here I chose to do 3 since that was a side and 5 is the base, and 9 since that was a side and x since that was a base. Then we just cross multiply and divide. On the test, I noticed some people were struggling with ones where we were asking were they proportional. Remember, if we're trying to figure out whether or not something is proportional, we just write both ratios, right, equal to each other. So imagine if I had this problem and instead of having x, I had 15. And I'm trying to figure out, well, is 3/5 equal to 9/15? Well, I could simplify 9/15 to 3/5 and see if that's right. But I could also just do 9 times 5 and do 3 times 15. When I see that I get the same answer for my cross multiplication, that lets me know they are proportional. So you might have some problems that are asking you to solve for x or find x, and then you might have some problems that ask you, are these proportional? So you need to know how to do both. Dilation. We talked about dilations recently too, so you should do well on this for the EOG. Remember, anything greater than 1, we're making it bigger. Anything less than 1 is a reduction. So here I have an example of us using a scale factor of 2. So remember, if it's a scale factor of 2, I'm just multiplying every number by 2, right? Because my figure will be twice as big. If it's a scale factor that's less than 1, a fraction, then it's going to be smaller, right? So here I'm making it half the size. So I can literally do 1 divided by 2, 2 divided by 2, 3 divided by 2, 4 divided by 2, and on and on and on and on, because I'm making my figure smaller. So dilations greater than 1, they're bigger. Smaller than 1, they're smaller. Transformation should also be familiar. Reflection, remember, if we are reflecting over the x, we change the y. We're reflecting over the y, we change the x. If we're sliding, we just need to know how we are moving, so that's the most important part, and everybody seems to be really good at that. A 90-degree rotation, remember, we just flip our x and y, and then we change our y to the opposite sign. And then 180-degree rotation, we're going to change our x and y to the opposite signs. So there I have -3 and -4, and so it just becomes 3, 4. Our quadrants, you need to know your quadrants, so this is something good to put on your EOG review. Remember, we plot our points by moving left or right first, so we always start at the origin. That's our starting point, 0, 0. We move left or right first, and then we move up or down second for y. So let's say I had the point 3, 4. I'm going to start at 0, 0, and I'm going to move to the right 3, and then I'm going to move up 4, and then I will plot my point. So that point would be in quadrant 1. You also might want to add to this what the signs are for each quadrant. So quadrant 1 is plus plus, quadrant 2 is minus plus, quadrant 3 is minus minus, and quadrant 4 is plus minus. And functions. Each input has only one output. So remember, we talked about how our x values cannot repeat with a different y value. So here I have 0 and I get a 5. Put in a 1, I get a 7. Put in a 2 and I get a 9. Now if I was to add to this list, I put in a 2 and get a 3, then it would not be a function, right? Because whatever I put on the left, it should have one output on the right. So if I put in a 2, I should always get a 9. If I put in a 0, I should always get a 5. If I get something different, then it is not a function. So my x value can only have one output. And then at the bottom, it just lets you know if you're already given a line, you can do the vertical line test with your pencil. And